All right, today is lesson 6.1. Starting chapter 6, we're going to be talking about rate of change and working towards talking about slope of a line and then the equations that kind of form lines and how we can pull slope from them and some other information. But starting today, just looking at the rate of change on a graph. And so your big idea, the rate at which a quantity changes, can be determined either by computation, which we'll look at today, also by looking at a graph, and then we're going to kind of connect the two. So your definitions, the rate of change, how much change is occurring between 2 points. So we're looking at a graph. Is from one point to the other a big increase, a big decrease? Is there no change across it? Okay, that's the rate of change. How fast a line is either going up across the graph, down across the graph, or not much at all. And the way that you're going to find it is using this formula. So you have 2 points on a graph. So this says x1 comma y1. Now the ones, they don't actually represent a number. They're just there to notate that this x value goes with point number 1. This is like point number 1. And this is point number 2. We just need to differentiate between the two so we know which one we're talking about, because this one's going to have an x value and so is this one. So we can't just call it x because then you don't know which one's which. Okay, so this is x1 and this is x2. Again, just referring to the fact it's coming from point 1, it's coming from point 2. The value is not actually 1 and 2. And then same thing with the y values. So we have a y1 from point 1 and we have a y2 from point 2. So if you want to find the rate of change, you're going to subtract your y values and you're going to subtract your x values. Now notice that it says y2 minus y1 and x2 minus x1. You actually can subtract it the other direction. Okay, you don't have to do 2 minus 1 and 2 minus 1 in terms of the points. You can go the other way, but you do need to be consistent. So if you were to go y1 minus y2 on the top, then you have to do x1 minus x2. So you need to go the same direction. You can't flip it, but you don't have to try and figure out, well, which one's point 2 because I need to start with that. That doesn't matter. Just be consistent. I'm going to subtract this point minus this for the y's, and then I'm going to match it and subtract this point minus this for the x, or vice versa. Now think about your y values on a graph. The y-axis goes up and down, so we're determining how much change there is from the y value. So we could have a point up here and another point down here. What happened to the y values? There was a big decrease. So when we subtract the y's, we're finding the distance between them. And so that's going to measure how much change there is up and down. And then your x2 minus x1, that's telling you how much change there is from left to right. Okay, so if I had a point here and a point here, their x values, they're not going to have a big change. But if one point's here and one point's all the way over here, that's a big change in x value. So that's measuring how much change there is from left to right. All right, I'm not going to worry about this definition right now. If you have it from your book, that's fine. But jumping into example number 1, we're going to complete the following table. So what does the rate of change look like when there's a constant increase, decrease, or no change? So first of all, if I was going to sketch what this is going to look like, I think it's good to start there. We're always looking at from left to right, and I'm going to go ahead and put that on all of these, just so we don't forget. Sometimes students are a little confused. Well, how do I know if it's going up or down? You read it from left to right, so you follow the graph just like you would read a sentence or read a word. Okay, and what's happening to the line? So we just have a graph. So if we have a constant increase, that's going to be a line that's constantly going up. It could be over here. It doesn't have to be going up extremely fast. These are both constant increases. But notice from the farthest point left, as I work my way across from left to right, it is going up the graph. The y value is changing in the positive direction. So a constant decrease is going to be the opposite. It's going down. A could go down much more slowly. These are both examples of a constant decrease. As you go from the farthest point left and follow that line to the right, the y value is decreasing. It's going down. And then no change, that's going to be a line that just goes straight across. All right, we're going to talk about what that means in a second. So this is what the graphs look like. Now we want to actually put a value to it. So a constant increase, when we represent it with a number, it's going to be a positive number. That should make sense. So you're measuring how fast this line is increasing. If it's going up, it'll be a positive number. The bigger the number, the faster it's going up. The smaller the number, like a very small fraction, that's still increasing because it's positive, okay, but just not as much. Constant decrease then is going to be represented by negative numbers. So if I say, what's the rate of change? Well, it's negative something. Well, I know then it's going down. So a smaller negative number, like a negative fraction, -1/2, something like that, would represent a small change, but it's still going down. It's a decrease because it's negative. And a large decreasing number would be like -10. Okay, a -10 represents a constant decrease that's going down extremely fast. All right, no change at all. So positive numbers are going up, increasing. Negative numbers are going down, decreasing. So if there's no change, then that means your rate of change is just 0. So when we represent this with a number, we're going to get 0. All right, as we slide down here, example number 2, let's calculate the rate of change between these 2 points. So first of all, let's imagine these points on the graph. 0, 8, and 4, 15. So here's 0, 8, let's say. 0, x value, 8y. And 4, 15, you'd go over 4 and then up 15. You'd be way up here somewhere, because if this is 8, then this is 15. So if I connected these with a line and kept it going, it's going to kind of look like this. So this is a constant increase. And because of that, we can already predict what's going to happen here with the actual number. So we're going to represent this increase with a number. It should be positive. If we don't get a positive number, we know we did something wrong here. So the formula that we're going to use looks like this. And so we're going to call this point number 1, and I'm going to call this point number 2. And again, it doesn't matter if you wanted to call them this 1 and this 2, that's fine. It's not going to make a difference. But you do need to be consistent. So I'm going to subtract my y values on the top, and I'm going to subtract my x values on the bottom. So my y values are 15 and 8. I'm going to follow the formula just so there's no confusion. So I'm going to take the number 2y minus the number 1y, which in this case is nice because it's a big positive minus a smaller positive, so that makes sense. So it's 15 minus 8. So again, this is x1, y1. This is x2, y2. So I'm just plugging in y2, 15, minus y1, 8. And then x2 minus x1. So here's my x value of 4. And then my x value of 0. Think about what would happen if you flipped it the other way. So if I look at this way, I'm going to get a positive on top. I'm going to get a positive on bottom. So I'm going to get a positive number, which is good. That's what we want. It's increasing. It should be positive. What if I flipped it? I had 8 minus 15 on the top. I'd get a negative up here. But then on the bottom, I'd have 0 minus 4. I'd get a negative on the bottom. And a negative over a negative is a positive. So they'll end up canceling. So you'd create 2 negatives, which actually cancel and make a positive, and you'd still have the same answer. Okay, so 15 minus 8, that's 7. 4 minus 0, that's 4. And you can leave it just like this. It's just fine to represent a rate of change as a fraction. Basically what this is telling you is the y value is changing by 7 and the x value is changing by 4. So it's going up 7, that's the y value, and then over 4, that's the x. Up 7 over 4, up 7 over 4, that's the rate of change. Now, if you actually divided this would be a number more than 1, right? Because 7 is bigger than 4. So any rate of change over 1, that's a pretty big increase. Pretty big rate of change. So let's look at the next one. So we want to find the rate of change between point number 1 and point number 2, x1 and y1, x2 and y2.